Members, we are proceeding with our episodes of statistics, and this particular video we are continuing from the previous video. So we were to talk about mode. Mode is the most common value in the data set. So if it is a mode for ungrouped data, we are going to just look at that data set and we look for the most common value. The most common value, for example, here is 7, and that will tell you that the mode of this data is 7. So what about if you have grouped data? This is how you calculate for this mode. Now, the formula is LB, which is the class boundary, lower class boundary of the model class. Then you can use maybe sigma, others can use D. So you can have D1 divided by D1 plus D2, everything multiplied by C. D1, first of all, LB is the lower class boundary of the model class. D1 is the model frequency or the frequency of the model class minus frequency after it, before it. Then D2 is the frequency of the model class minus frequency after it. Then this is the class width of the model class. How do we determine the model class? Is that class with the highest frequency. So let us proceed and look at mode of a class that has mode of distribution that has the equal width we have seen. This is what we use. But when we have an equal class width, this is the formula that we use. We are going to determine what we call the frequency density. And frequency density is frequency divided by class width. So the formula will be lower class boundary plus now this one divided by this plus that, then times C. Now, what is the lower class boundary? The lower class boundary that we're talking about is that of the model class. The model class here for this kind of scenario is the class with the highest frequency density. Not highest frequency, but highest frequency density. Please mark that. So what happens? The class width is C. So the class width C is the class width of the model class. Now, how do we get this value? Sigma F or df dot d1. This is going to be the model frequency density or frequency density of the model class minus frequency density before it. Then this one is the frequency density of the model class minus frequency density after it. Take an example where we have max 10 to 19 up to this value 65 to 79 with their frequencies. We are asked to calculate for the mode. If you are told to calculate for mode, this is how we do it. First of all, you're going to construct a frequency distribution table. You put your class boundaries. So these class boundaries, you always subtract 0.5 from the lower class boundary and you add 0.5 to the upper class boundary. So if I had 10 minus 0.5, I would get 9.5. Then in 19, I add 0.5 to become 19.5. You do the rest. You do the same for the rest. This was 20 minus 0.5, you get 19.5. Then 24, you add 0.5, you get 24.5. You continue, and this is the frequency density. How you get the frequency density? You need to get the class width. Class width, you get 19.5 minus 9.5, you write here. 24.5 minus 19.5, you write here. 34.5 minus 24.5, you write there. You complete for the rest. Then your frequency is given. Get the total frequency, and here you have 40. Now, how do we determine the class, the lower class boundary, or how do we determine the model class? The model class, we said, is that class with the highest frequency density. So this is going to be 19.5 to 24.5. So when I reach here, I'll just pick my 19.5 because it's what I need to use here. Then C is 5 also. So now the model frequency density minus frequency density before it is going to be 1.2 minus 0.4. That is what you see here, 1.2 minus 0.4, then plus. Now, the model frequency density, the frequency density after it is 0.7, so it will be 1.2 minus 0.7. So that one I multiply by 5, then that value plus 19.5, I'll have my mode as 22.58. So what about the quartiles? Let us talk about quartiles. The quartiles, they are divided into four. You have your data that is organized in ascending or descending order, and you have organized it into four values. Four equal portions. So those four equal portions you have from 0 to the 25th. So to 25th, that will give you the first quartile value. Then the second one, Q2, would give you the second quartile. And this is usually equivalent to median. Then the third one is 75th, what we call the 75th percentile. This is going to be the third quartile, then up to 100. If you want the interquartile range, it would be Q3 minus Q1. And we use this to measure dispersion between the data. So if we want to get the quartiles from OGIF, obviously you need to get the cumulative frequency of the distribution, plot it against the points that you have. So what is going to happen is you're going to, for you to get the 25th or the first quartile, what is going to happen? You get 25 out of 100, or a quarter of n. For example, if I'm talking about n is the total frequency. So if n is the total frequency, then my first quartile is going to be identified from a quartieth of n. So a quartieth of n, when I reach there, I'll get that value, 1 over 4 times the cumulative times total frequency. Yes, that will be the total frequency. So when I get that value, I go to the cumulative frequency curve. So if, for example, my n is 100 and the first quartile is going to be 25. So I just got 25 on the cumulative frequency. I move until I meet the curve. I go horizontal. Down there, that's where I'll read my my first quartile mark. The median is actually going to be the second quartile, and this is always going to be 50 out of 100, or a half of n. A half of nth value. So what you get, if your n is 100, then it will be 100 divided by 2. It will be 50. So 50, I come here, I will meet the what? The curve, and go down, read off that value. That will give you the second quartile mark. The upper quartile is going to be a third of n. A third of nth position, so not a third, but the 3/4 of n. So 3/4 of n, that is 75%. So I go to 75. I got 75 here and move to the ogive curve. I go down. The value I'm going to read here is going to be my third quartile mark, or what we call the upper quartile. So to get the interquartile range, obviously we said it is Q3 minus Q1. So as we have already said, we said Q1 is the value below which 25% of the data falls. Median is the value, or the second quartile is the value below which 50% of the data is going to fall. Then the third quartile is the value below which 75% of the data falls. So the formula is, if we have any grouped data, we said if n is odd, then you do just add 1. Okay, so that would be a quarter of n. Okay, a quarter of n value, that is 4. That is going to be your first quartile. Then the second quartile is going to be a half times n's value. So you do just have that. Then 3/4 of n. Okay. So if n is of course is odd, then we would obviously add that 1. So for grouped data, the first quartile would be calculated by this formula. L is the lower class boundary of the quartile class. How do we get the quartile class? We always get a quarter of nth value. So that value we will go to the cumulative frequency table, and then we will be able to locate a value which is close to n out of 4. And then we shall just go to that side of class boundaries, and then we will be able to locate a value through the cumulative frequency which is close to this, and then we will be able to determine the class from there. Then cumulative frequency is f, and this small f is frequency of the quartile class, n is the total number of observations, h is the class width. So the first quartile is equal to L, the lower class bound of the quartile class, plus n out of 4 minus cumulative frequency of the class before the quartile class. So this is cumulative frequency before the quartile class. Cumulative frequency before the quartile class divided by frequency of the quartile class. Everything I multiply by h, which is the class width. Others use c here, others use c fb, like this, to tell you that is the cumulative frequency before the quartile class. The second quartile and the third quartile, their formulae are here. And of course, to get the second quartile, you need to determine the second quartile class, or the median class, which is always going to be n out of 2, the value. Then you go to cumulative frequency, the value which is close to that, then it will show you the class boundary. So the class boundary, you go and pick the lower class boundary for this second quartile class. The third quartile also do the same thing, only that what differentiates them, for this it has n out of 2, or sum of frequency divided by 2. Here, this one has 3/4 of sum of frequency, then minus cumulative frequency before the third quartile class. Okay. So H, others use C as the class width. The percentiles are almost the same way, only that here we are talking about percentages instead of quarters. So in percentages, you have maybe the first percentile would be 1 out of 100 times the n. So you get that term. But if it is odd, then it will be n plus 1. How about the we are saying k is the desired percentile. So if, for example, you want to say the 50th percentile, it will be P50, will equal to 50 divided by 100 times n plus 1. That is if n is odd, plus 1. If it is even, you don't need to add that 1. For grouped data, this is for ungrouped data. Then for grouped data, it will be now kn, like 50n divided by 100, whereby n is the sum of frequency, minus cumulative frequency before the percentile class, the 50th percentile class, divided by the frequency of the percentile class, times C or H, which is our what? Our class width. So K is the desired percentile, lower class bound of the percentile class, cumulative frequency, class width, and that's all. So for range, we can determine the range. Range is the maximum minus minimum, and that one is very, very easy to calculate. Then we can also look at the measures of dispersion. If this is too fast, you can pause this video and write these formulas. Write them down and you'll be able to utilize them. Variance means the measure of how far values are from the mean. How far the values are from the mean. So this proof, no one is going to ask you to prove, but we have put it here for you to understand. So the formulas that you're going to use for variance is going to be sum of fx minus mean, everything squared divided by sum of f. Or you can say sum of fx squared divided by sum of f minus the square of mean. For inferential statistics, the sample variance S squared differs from population variance. The standard deviation comes from the square root of variance. So this is your formula for variance, or this. If you have assumed the mean, if they told you you assume the mean, then this formula is the one that you would use. Then standard deviation would be the square root of variance. Take an example, look through this example and try it out. Then I believe you will enjoy. So, ladies and gentlemen, thank you for tuning in, and make sure that you try out these numbers. Get a pen, get a paper. Where we are very fast, you pause and first note down whatever you want to note. Thank you.